and gentlemen, friends, Romans, countrymen, lend me your ears. Let's talk about what's going on. So housekeeping. So first of all, this is HL1, and we're going to be dealing with geometric series. And if we get lucky, we'll deal with sigma, but we'll deal with that in a moment. Okay, so this is where we are. Now, housekeeping. Okay, so this is an IB course. I've talked to you guys about, deadlines and things like that, and it's all in the syllabus. So what I'm going to do is I'm going to release. You don't have to copy this down. I'm just telling you what I'm doing. I'm going to release my answer key to the IB problem set. Well, I'm going to talk to you about it, and then I'm going to email it. I'm going to talk to you about it, show it to you right now, and then I'll post it up on the Canvas page. You have a homework due next class. And you have a homework on an announcement that's a new homework. And that is due on Monday by 8 a.m. And I will be releasing that answer key at 8 a.m. And then I will be having office hours just for this class on Monday from 11 a.m. to 12 p.m. as the test review. So before we get started on any of that, go ahead now and pull up the homework assignment that I just posted on the Canvas page, because I'm not going to have you do every problem. You've seen a couple of them already. So the only questions that I want you to do are 4, 6, 7, 8, 9, and 10. Those are the problems that you need to do for the homework assignment that I've posted on the Canvas page. It's under announcements. It's an attachment to it. So they're actually not too bad. Okay. You'll have next class to answer questions, but we're going to cover all that material today. Okay. Now, a number of you have not turned in the IB problem set that was due today. It was supposed to be due 5 minutes ago, 6 minutes ago. And I don't have time to wait to give you the answers for that one at another time. So we're going to go through it. Now, those of you who have done it, this is an important thing because I'm going to show you how I grade it. All right, one second. So can everyone see my screen? All right. So I want to point out that if you were to look at the document, in the corner of each problem, it said how many points it was worth. Now, this is what I'm talking about when we talk about these points. This is what's called a mark scheme. All right, there are three kinds of points. There's M points, A points, and R points. Um, um, M is a method. A is an accuracy. And R is rare, actually, but it doesn't mean rare. It means reasoning. Okay, so for example, if we, and we're just going to do a couple of these, and I'm not going to go too deep into it, but I kind of want to teach you how this is graded. All right, so first of all, this is my work. When, you know, I've talked about having flow, having, you know, space, and clarity, this is kind of what I'm talking about. All right, so I've listed some information, and I asked the question, you know, find the n. You know, that's what's going on here. I didn't have to write out the whole problem. I just said, hey, find n. Now, you get a method point for using the right tool. And then you get an accuracy point for executing the tool properly. Okay. Now, the next phase was figuring out what tool you needed to get the sum and then the final answer at the end. So if all I see is like mental vomit that doesn't make any sense at all, and you get 88.97, fantastic. You're only going to get 1 point because I can't give you these. All right. I need to see some of these things. Now, sometimes, you know, if you were to, you know, write it up maybe in a slightly different way, you know, you might still get the method point even if I don't see that line, but that's not very common. All right, so the second problem, again, using the right formula to come up with one of your equations, and then using it properly and getting the other equation. So we've got two parts here. I don't care how you solved your system, as long as you did solve your system, or you set up a system, and you get your final answers as your last point. So it's all about the mental hoops that you have to jump through, okay? Does anybody want to look at any one problem in particular? I'm going to be posting all of the answers on the announcements. Does anybody want to look at one in particular?
Can we do number 3? I struggled with that a lot.
Sure. Okay. Yeah, if you haven't given me your email, your homework, you have literally 5 minutes to do it right now. Yeah. Yeah. Do that right now. Okay. You want to talk about number 3? Okay, number 3. Okay. So in number 3, we had the ratio of the 5th to the 12th was 6/13. They said that the terms were greater than 0 for all n. And then the product of the first and the third, let's see if I can get a little better here. The product of the first and the third is 32, and we're supposed to find the sum of the first 100 terms. So taking this equation and cross multiplying it gives me M1. Now, so I get a point just for interpreting the answer, interpreting the information, and coming up with something. Now, writing A5 and A12 as in terms of A and D, this is a whole other method right here, because this is a different tool. Interpreting the problem gives you 1 point. Turning A5 and A12 into things that you can actually use, that's another point. Now, this one's in parentheses because I don't necessarily have to see this if I see that. And if you were to come up with the whole thing, that's another point right there. Then we use the other piece of information, substitute A3, distribute, and then substitute, or however you did it, but usually A would be the one to substitute. Substituting into here gives me this. Now, here's an important point. When I simplify this whole thing down and I get d squared is equal to 4, square rooting it gives me 2. But we don't want the negative 2, we want the positive 2, since all elements are greater than 0. And that right there is a reasoning skill. Okay? That's they don't pop up very often. And usually they pop up when like you have to throw out an answer, or you have to round somehow in order to make your answer work. Okay, but like there's like you got your answer and then you had to think about it is when a reasoning point comes in. Like I said, they're very uncommon. You might go an entire IB exam and never, like a whole exam, and never see a reasoning point ever. Okay, but they sometimes pop up like that. And then once we've got all this information, we know what D is, and we know what A1 is in terms of D. I use both of these pieces of information to come up with the final number at the end.
Okay, I see where I messed up.
Cool. Any other problems people want to talk about? No one? Bueller? Bueller? Wow, you guys don't even recognize that one, do you? You guys are too young to know who Ferris Bueller is?
No, I think we know. I know who it is.
I know.
Oh man, you guys are culturally deprived. All right. Emma, you look like somebody just, kicked your dog. You all right? All right, cool. All right, so let's go back. Let's talk about some new material. Oh, by the way, does anybody have any questions on the homework that's due next class? Anybody? No questions on that one? Show of hands, who's done something about that homework already? Oh, you guys. Cindy's got this like devilishly, suspicious look on her face. She's just like, I busted. All right, let's do this. Okay. Dun, 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 dun. Let me zoom a little better. Okay. So geometric series. Okay. Now, for a geometric series, there are two scenarios that we care about: finite and infinite. Right now, we're going to start off with finite. Okay, so let's make a example, and we'll use an example to come up with our formula. Okay, so let's say the sum of the first 4 terms of a geometric sequence are what we're interested in. And we know that the sum of 4 geometric sequence terms are going to be the first one, plus the second one, plus the third one, and the fourth one. Okay, now, since I don't want 4 different variables here, what I want to do is I want to turn these g's into something that doesn't have all sorts of different variables. And to do that, I'm going to realize what G2 is. G2 is G1 times R. And then G3 is G1 and 2 R's. Remember, that was the formula that we got, right? You use R to make the next guy down the road. and then G1, and then 3 of them. All right. So now what we really, really want at the end of the day of this thing is we want a formula that says, give me some information and I'll tell you what the sum of those terms is. Okay. So whoever figured this trick out, I would like to buy a cup of coffee because this is a sneaky trick. Okay. They went ahead, and we're only really interested in this bottom one here because this is kind of like the idea behind it, but this is the math. So if I take my equation here and I multiply everybody by R across the board, so now I've got okay. And then what we want, if we look at this thing carefully, we'll notice that we've got common terms in each of these sums, right? These two are the same, these two are the same, these two are the same. That one and this one are not, okay? So what we can do, and this is the sneaky thing, is I'm going to take this equation and I'm going to subtract this equation. And we get now, if we look at that, this guy is going to stick around. But this is all of these fellas down here are going to become negative, and they're going to go ahead and cancel out with the fella above it. And all that's going to be left is this last fellow right here. So before we go any further, I want to make sure that everybody sees this like cool little trick that we did in order to come down to this, we're not done, this simpler equation. It's simpler because it doesn't have like 100 terms on it, right? So now what we can do is, first of all, what I'd like to do is I'd like to generalize it. You know, we used a simple example of 4 terms, but I could have just as easily used 400 terms, right? So this 4 and that 4 are only specific to this example. So I'm going to rewrite it in general. Okay. And now we're going to factor out some GCDs because we can. And now I'm going to solve for S of n, because this is actually what our goal was to find that sum, whatever that sum is. And this is your finished formula. This one, go ahead and put in your grid, that notes grid that we had. And this is the finite sum a geometric And it's important to write finite. We'll talk about infinite later. How we doing? We good? Everybody's chilling? Okay. Let's do some examples. Oh, where'd you go? Okay, let's do this. All right. Ooh. So I'll walk through this one. Maybe you can do it on your own. This is my G1. I have to find out what my R is. So dividing successive terms. Okay, wait, did I? 150, 175. Whoops, that's wrong. That's a 7. Oops. So I am multiplying by 5. So that's my R. And 10 is the number of terms. So the sum is equal to G1, 1 minus R, 1 minus R to the nth. Okay, so now let's burn through it. 7, 1 minus 5 to the 10th, 1 minus 5. Now, some of these you can do without a heck of a lot of pain, okay? But 5 to the 10th, that's pretty darn big. So this is where a calculator comes in nice and handy. Nine seven six five 624 divided by -4 times 7. Did we get that one?
Can we leave our answers like that, or do you want us to put like the sum of the 10th term is that?
Oh, you mean like something over here?
Yeah, like when we write it, can we just leave it like that? Like
You
we
know,
won't points?
I'm not that super picky, but I mean, let me put it to you this way. If there's any confusion about what you're doing, then you absolutely should put this here. But
Okay.
if like you're doing this, if, if G equals math, 7,
Okay.
I'm cool with that because this hasn't changed, right?
Yeah.
but
just want to make sure that we won't like lose any points for not.
nah, look,
Okay.
no. It's not about points, man. It's about form and it's about clarity. And so, I mean, like, I'm not gonna kill you in Nietzsche about form. Well, that's not true. I will kill you in Nietzsche over form, but I won't make it. I won't. Your grade won't necessarily suffer unless I can't read it or if it doesn't make sense. So that's why form is important because the it's about the distribution of your ideas. So if there is confusion about what's going on here, I mean, if you've got like things going on and then all of a sudden M is this and then N is that, and I really, if you've got things going on over on this side, like 7 plus M, squared or whatever, now I don't know exactly what 7 is. You see what I mean?
Yeah.
And then in that case, you would say N is 7 or G is 7 or whatever is 7,
Okay.
right? But if we're only talking about one thing, then nah.
Okay. Thank you.
Sure, man. Now, all right. Let me do this so I can read it. All right, let's do this one. A little different. First term, -6. -3. $13,122. Okay. And we want to find the sum. So let's think about it this way. In order to find the sum, I need G1, R, and N. Well, I know what G1 is, yay. I know what R is, yay. We know what the last term is, but we don't know what N is for that, okay? So what we're gonna do is we're gonna find out what is the N for this so that we can use the formula. So if we know what the term is, let's go back to our formula. So the G sub N is G sub 1 R to the N minus 1. Now let's go ahead and plug in all the stuff that we know and find all the things that we don't. So 13122 is equal to my first term, which is -6. My R is -3 and minus 1. Okay. Now I'm going to divide both sides by 6, and that's going to give me -2, 3, 5. Wait, no, wait. 2, 3. Well, that's not right. Two with a remainder of 1, and then 1. That's it. That was my mistake. That's a 1. 5, 2 gives me 48, which is 8, and then 7. Okay. And now think about it this way. Whatever the heck this is, these are just -3s times -3s times -3s over and over and over again. So let's go ahead and compute what this is. 7, 2, 9, 3. Use the fundamental theorem, right? Because we're going to break all these things down. So this is 2, 4, 243, 381, 327, 3933. 1, 2, 3, 4, 5, 6, 7. This is 2 to the 7th. 3 to the 7th. And that means that 7 is equal to n minus 1, and n is equal to 8. How does that feel? Cindy's like, yeah, if you say so, dude, whatever. Cool. Bennett's like, stop talking, just give me the problems. Just want to solve them now. All right, let's keep doing some more. All right. Okay. The 9th term is 50. The 13th term is 0.08. Okay. And the last term is 0.0032. Find the sum. Okay. So whenever they give you stuff that doesn't really apparently look like it helps you, do yourself a favor, take these 3 pieces of information, turn them into equations. So let's look at this one. So 50 is G1 R to the 9th, right? So this would be 8. And we also know that, and so this is 8/100ths, so it's 4/50th. Okay, I mean, like, you could, you know what? I like fractions, but I don't think anybody here likes fractions like I do. So let's just do it the way you would do it. And since this is the 13th term, I need 12 R's. Okay. And the last piece of information says to me that now, we don't know what R or N or G1 is. We're just going to leave that alone, and maybe we'll come back to it later. Okay. Now, I got these 2 equations. And what I want to do is I want to use, because remember, if I've got 2 equations and 2 unknowns, I should be able to solve it. So one way that we might be able to do this, even you could do substitution if you really, really wanted to. But, you know, you could maybe do it. Well, what do you want to do? How might you do it? Anybody got an idea? How can I simplify these 2 equations and 2 unknowns? Has anyone ever heard of this word? An obelus? Has no one ever heard of the word obelus? You've been using an obelus all of your lives. That is an obelus. That is the name of that symbol. Yeah, y'all didn't know that? You guys using the symbols and you didn't even know their names. That's okay. So let's divide them. So and the beautiful part about division is that it's just going to knock stuff out. And I have 12 R's up here, 8 R's up here, and down here, so therefore when they start canceling, I am left with just 4 of them. Now, this is where life becomes a little bit easier if you know how to deal with fractions, okay? And this turns into 2 over 25 divided by 50. And so the answer to that is 2 all over 1250 is equal to r to the 4th. Oh, 625, not, I lied. Is that right? Yeah, because
I
there's
think you
2
just
of
have
them.
to simplify it.
Yeah, I can, and that's, yeah. Yeah, because they're both even. And that's 1 all over 625. And if we're sneaky about this, we hop on off and we do our, now, my flow in this problem isn't so exciting because I'm trying to do this, first of all, in marker, which you should never do, and 2, trying to fit this onto a single page, which you should never do. Kill trees, people. Kill trees. Lots of trees. If you're worried about trees, buy a Prius. Okay. Yes, I drive a Prius. Okay. So 625, that's 5 and 125, 5 and 25, 5 and 5. So this is 5 to the 4th. So this tells me that, and I'll just run out of room here, r to the 4th is equal to 5 to the negative 4. Right? So that tells me that r is equal to 1/5. Yay. Now we got to find all the other nuggets of information. Like, and remember, to use the formula, we need G1, we need R, and we need N. Okay? So let's go up and do one using some information that we have. So 50 is equal to G1, 1/5, and this is the 9th term, so there are 8 of them here. Okay. And now we solve for G. So G1 is equal to 50 times 5 to the 8th. And I'm just going to make my life easier here and say it's 2 times 5 to the 10th. Because 50 is just 2 5s, which will give me 10, and a 2, which is that. And you can multiply that out, but there's really no need to, because in a minute we're going to be done. All right. Now we got to find out the number of terms. So we have G1, we have R, we know what this is equal to. Now we need to find what our sum, what the number of terms is. So, okay, so 0.0032 is equal to 2 times 5 to the 10th times 1/5 to the n minus 1. And if you're comfortable with your fractions, or if you're willing to do it, this is 2 all over 625. 2 times 5 to the 10th. And let's start canceling some stuff out. And so this is 5 to the fourth, negative fourth. Solving. And you're done. Oh, but now we need to find the sum. So we've got all of our terms. We know that there are 15 terms. R is 1/5. N is 15. Now let's simplify. I mean, yes, you could probably put it into a calculator, but it's just as easy to do it by hand. And this is now 1, and you can do this in many different ways, of course. And that's about as simplified as you're probably going to get it. And then, of course, you put it in the calculator. Okay. Now, second. All right. Let's do one that's a little tougher. That was just a whole lot of work. Okay. You want to try that one? Yeah, you will need a calculator, of course, to solve this one. And I would recommend solving it graphically. Who's lost?
I'm very lost.
Really? Okay. I love that. That's great. That means that we're talking about something that we need to practice. Okay, so let's walk through it. The sum of the first four terms is 1. And we're dealing with 4 terms. And we know what G1 is, that's 10. So we've got and now some people are sitting around saying, what do I do with that? Right? Okay. First of all, you've got 2 polynomials here. So that means you should divide them. So let's do that. I've got, and I can rewrite this if I want. And now we divide them and you wind up with this polynomial. You can do like synthetic division, or you can do long division, however you please. Or you can do this. You can factor it. That's what actually I did. And to multiply those out quickly, realize, I mean, remember how I showed you how to multiply polynomials quickly? This polynomial is 1, 0, 1, and this polynomial is 1, 1, and 101 times 11 is 1, 1, 1, 1. So this is 10 r cubed, r squared, r plus 1. And then you can either distribute it out and then subtract the 1, or graph both of these and find their point of intersection. And when you do that, oh, I went ahead and distributed it out. And you get a graph that basically looks like that. And then you find its point of intersection, sorry, it's 0. And there's your x. Negative 0.9473. All right, judging from the amount of anxiety over that problem, let's do another one. Okay. You want to try it on your own? I don't think you can see Fernanda right now, but Fernanda's saying, like, in her, I can see it in her face. She's just like, dude, are you serious? Ferris is asleep. All right, work on this one for a few minutes. We've only got a little bit of time left. Who's drowning? That's it? Just do? Oh, come on. Okay, let's do it. Guys, this is done mainly in the calculator. So first of all, did everyone set up this equation? Okay. So I divided both sides by 12. And now I've got this guy. Now, believe it or not, you could stop right here, put that into the calculator, and it'll give you your answer. Graph this side, graph that side, find the point of intersection. So technically, you don't have to do any more work than that. But if you didn't have a calculator, you've got the difference of squares, and then you've got the difference of cubes, and then you've got this polynomial times that polynomial, which is that polynomial. And then I move this over to the other side. Combine like terms and then graph it, and that's your answer. And that's it. So a lot of times when you're finding R, it's a calculator job. Because no one's going to be able to easily factor that term. That's not an easily factored polynomial. Theoretically you can probably come up with good estimates, but it's just easier to use a calculator. But up here, you get the exact same answer. You just put in -6665 and 1 minus x to the 6th divided by 1 minus x. And then you just find the point of intersection, -6. But if you're going to do that, then at least tell me, just do this by calculator. Okay, just let me know what step you used to use when you use your calculator. Okay, because you found a numeric answer, right? Versus an algebraic answer. Okay. I'm a little nervous, everybody. Everyone's kind of feeling a little overwhelmed on this one. You should see Emma. She's on fire right now. There's smoke coming from behind her. Either that or something's on fire over there. But so everyone pull down that document. If you haven't already, let's take a look at it. So I will share my screen. All right, you're not doing 1, you're not doing 2, you are doing 4. You know what? Show of hands. Who sucks at logarithms?
Me.
Oh, snap. This is no happy. Okay. You can't see it, but I've got a sad face. Okay. Skip number 4. Gosh, you guys. So it's just the 3rd, 4th, and 5th pages. It's just 6 through 10. Now, we haven't done an infinite geometric sequence. We were going to do, oh, wait. Yeah, we haven't done that. We'll deal with that one next class, infinite, okay? But it's only one question, so you can do that over the weekend. So I'm not eliminating that question, but you'll just have to hold on to it, unless you already know how to do it. You'll hold on to it until next class, okay? But it is being assigned. And that's infinite as well. So these two are infinite. Okay, so that's okay because we've only got 2 days between now and next class. So this looks pretty normal. How many of these are infinity? That's what I did last year, but last year, okay. All right, you know what I'm gonna do? In case anybody's feeling excited about it, but we'll do this next class. This is the formula for an infinite sum, in case you just want to do it. That's the infinite sum. And then I'll explain where that comes from next class. But in case anybody wants to jump onto those problems, they can. So 6, 7, and 8 have infinite pieces to them. 9 doesn't have any infinite, so you can do that one right away. 10 is arithmetic and geometric put together. And that's it. So it's really, really, really not too bad. We haven't talked about values of x does it converge, but you can actually solve B if you wanted to, but we'll talk about this later. That's all next class. But it's really only, I mean, for crying out loud, it's 5 questions. 6, 7, 8, 9, and 10. And 9 and 10 you can do right now. Come to class next class with questions. Find me during office hours. My office hours are right after class, like in 5 minutes. Okay? So if you have issues, moans, whines, complaints, hop off this call and hop onto my office hours call. Okay? And we'll work it out. Now, private chat. Everyone send me a message right now. Scale of 1 to 5. How you feel about all this? Private chat.
Is 1 like not
1
good?
sucks. 1 sucks. 5 means you're kicking it. Okay. Got a pretty broad range. I didn't see any negative numbers, which is good. All right. If you're not coming to office hours, I will see you on Thursday. I will be posting my answer keys to the homework that was due today as soon as I get out of office hours. Okay? All right. Have a great day, everybody.
Bye.
Thank you.
Bye.
Thank you.
Good day.
Thank you.
Yeah.
Oh, and just to double check, did you get the homework that I emailed to you for today,
Today? Who is this that's talking to me?
Jacob?
Jacob. Oh,
I
snap.
sent it on the 22nd, I believe. Actually, no, not today's the 22nd. What am I talking about?
I don't know what you're talking about.
I sent it Saturday.
All right, give me a minute. I had 137 emails from my geometry classes,
Ooh, oh my gosh.
and I graded every one of them. Gave them feedback too. Jeez,
Dang.
you know? Oh my God, I've got so many freaking emails. Okay, no, this is who I'm talking to?
Jacob.
Jacob. All right, let me pull up the folder. Arithmetic homework block 6, Saturday, 1:22 a.m. Yep, I got it.
Got it.
I
Thank
have
you.
not read it yet.
Oh, that's
Okay,
all right.
so, well, but here's the deal. I got through all of my geometries, and I've only got 11 HL1 papers left to do.
Sure, just take your time. Take your time.
Oh, no. You guys got to know what's right and wrong on this one.
Oh,
So I got to
true.
get it to you. I got to get you your answers back and give you my answer keys. So, you want to be able to compare your work to mine if you didn't get it right.
Mm-hmm.
Okay. So what time is it? It's 2:45.
Mm-hmm.
Okay. I'm going to do everything in my power to be done by 8 o'clock tonight. So keep your eyes open on your email, and I'll get you your feedback and the answer keys ASAP.
Mm-hmm. Got it.
Okay.
Thank you.
Not a problem, Ben. I'll talk to you later.
See ya.
See ya.